Hello everyone, welcome to the second virtual IoT webinar. I'm here with Benjamin Cabé. He'll be talking about the Eclipse IoT stack and having a cool demo. So Benjamin, it's up to you.
Thanks, Roxanne. So, yep, second webinar. The idea today is to show you something very practical. It's actually going to be probably pretty technical compared to last week. And yeah, I want to talk about things like Kura, Californium, Paho. How can you use them, put them together, and build your own end-to-end IoT stack? So let me share my screen. Alrighty. So yeah, the pretty lengthy title is how to build the IoT with the Eclipse IoT stack. And as I said, we're going to use a practical example. So before I start, just to remind you that whether you're on YouTube or on Google Hangouts, you should be able to use the Q&A to ask any questions that we will answer at the end. And otherwise, you can use Twitter and the hashtag #VirtualIoT for sending questions or commenting and sharing your thoughts on the webinar. So IoT, and what do I mean by an end-to-end IoT solution? Well, nothing very fancy. You will probably have on one end the real world, right? The actuators and the sensors that will sense the temperature of your house, or that will allow the actuators that will allow to open or close your door or control your car, etc., etc. And these sensors, they are usually connected to the internet by means of a gateway, and we're going to see what is a gateway and what are the requirements for building an IoT gateway. And then most of the times you would have a cloud backend, a server backend, basically in between the user front end and the sensors. You probably want to have some kind of cloud backend that will do things like data consolidation, data analytics, allow you to manage a large fleet of devices. But well, sometimes you actually won't have a cloud, right? You will just build solutions where you basically talk directly from, say, a mobile front end or a web application. You can actually talk directly to your IoT solution. So in order to connect your sensors, your actuators, in this practical example that I want to talk about today, I want to say a few words about a pretty cool open source technology that's called Pi4j. It's basically, well, what I want to talk about today is how you can use, for example, a Raspberry Pi, right, to build your solution. And so one thing that is not that easy when you have when you want to use, for example, the Java programming language, is to have a nice way to access the underlying GPIOs of your system. You can, for example, you can use directly the sysfs API, right? But if you want to like really do fine monitoring of the GPIO states and stuff, you really need to have some kind of more native implementation, which is exactly what Pi4j is about. So it's a Java API for doing GPIOs, I2C, SPI. It's very mature. It's based on the wiring Pi C layer, and it also comes with support for nice external shields, Raspberry Pi shields like the Pi Face or the Gerd port. These guys basically do analog. For example, you may know that there's no ADC in the Raspberry Pi, so you can actually use external boards and have support for that in Pi4j. It has lots of code samples, and actually one code sample would be like this. So yeah, basically just a couple lines of code. You instantiate your the GPIO pin corresponding to, say, an LED, and you want the LED to be initially with a high state. You want the LED to be turned on, and then you wait for 5 seconds and turn it down, turn it up. You can toggle, you can release the GPIO. Well, that's really a very simple API for doing GPIOs, and obviously there are many other libraries out there for doing CAN bus, Modbus, etc. So that's kind of the easy part, right? Talking to the sensors, probably reusing some kind of external libraries. But then comes the moment where you actually need to bridge those sensors to the internet. And for this, at some point, you will very likely have a gateway, right? Basically a computer that's probably way more powerful than your sensors. Sensors are probably some kind of microcontrollers, or basically very small dumb chips. And you want to use a gateway not only to connect the sensors to the world, to provide them basically with internet connectivity, but also to manage the sensors, manage basically all the hardware that's helping you build your IoT solutions, right? Your sensors, your wireless modem, maybe your Wi-Fi module and stuff like that. And you also want to manage all the software that's running at what I call the edge of the network, right? You want to make sure that you have a way to update the software over the air. You want to make sure that you can update even the firmware, maybe of your wireless modem and stuff like that. So in terms of connecting, what are the options that we have? Well, we've actually talked about these protocols last week already. There are many others, right? But again, today in this very practical example, I'm going to focus on CoAP and MQTT. So CoAP stands for Constraint Application Protocol, and it's basically a way to expose over UDP resources, RESTful resources, like you would do with HTTP, right? So with CoAP, you can expose your temperature sensor, your LEDs, etc., as resources. And then there is the MQTT approach, where your gateway is actually going to talk to a server, to a broker, and you can use the MQTT protocol to publish data to the broker, and later on other clients might subscribe to the broker, like a mobile application, for example, will subscribe to the broker and be notified whenever data is available, whenever a gateway somewhere will have published data, any consumer will basically be able to receive that. So how would you use CoAP? Well, at Eclipse, we have a nice open source implementation of CoAP in Java. It's called Eclipse Californium, and it's really easy to actually build an application using Californium. You have basically three main classes: the server, the resource, and the CoAP exchange, which basically models the request response mechanism. So how would you build a CoAP server on your gateway? Well, you create your own implementations of CoAP resources. You add them to a server, like you mount the resources, right, under specific paths on the server, and you start the server, which basically would look like this, right? That's how you would implement a resource. You can implement the get, the post, the put, and that's basically it. So in a few minutes, we're actually going to see how to build a real CoAP application, and it's going to be actually very similar to this example, obviously. That's for Californium, and for PAHO, it's also very simple to manipulate the MQTT APIs, thanks to the Eclipse PAHO project. So again, in the context of this webinar today, I'm really focusing on Java-based technologies. So PAHO provides MQTT client implementations in many languages, including Java. And the Java API would look something like this. You connect to a broker. You implement a callback that will be called whenever there is messages that are available and you're interested in, and you connect to the broker, and you can then oops, you can then subscribe to specific topics, and you can publish messages as well if you wish. So that's for connecting. That's again not so difficult, right? I mean, that's basic IT stuff, I guess. And then the tricky part then that is often that many people usually forget when they think about building their IoT solution is when you build an IoT solution and applications that will be deployed on embedded devices on the field, right, remotely, then you need to have a way to manage all these devices over the air. You don't want to go on the field, deploy new software packages on your home automation or home alarm systems, or you don't want all the cars, all your IoT-enabled cars, to need to come back to the car shop to be fixed if there's a bug, right? You want to manage the gateway itself, like the internet connectivity of the gateway, and probably you want also a way to manage the wireless modem, the firmware of the wireless modem. You want to be able to manage the applications running on the gateway. You want to be able to install remotely a new version of your home automation controller, for example. You want to start the application, stop the application over the air. And you want, in general, we want a way to manage all your sensors, and you want some kind of hardware abstraction layer, right? So you probably learned about that if you were there last week for our first webinar. We have actually a solution for connecting and managing IoT gateways. It's called Eclipse Kura. It's based on Java and OSGi. So OSGi is basically a Java component system for Java that allows to build modular applications. And so basically in Kura you have all the modules and the APIs for building an intelligent IoT gateway, as well as to build your own IoT applications that will be deployed in this gateway. So in order to install Kura, again, I want to be very practical, and I want you guys to be able to try out all these technologies right after the webinar. I'm again targeting the Raspberry Pi. So if you want to test Kura on a Raspberry Pi, it's actually very, very simple. On a brand new Raspberry Pi, you would run. You would first make sure that your aptitude repositories are up to date. And then you basically download the Debian package for the Kura distribution. You install the Debian package. You make sure that Aptitude installs all the third-party dependencies that Kura depends on by issuing this command over here. And you reboot, and basically you end up with Kura running on your Raspberry Pi. So what can you do with Kura? And right after this slide, I'm actually going to show you live how Kura looks like. It allows you to do things like managing the network. You are basically building an IoT gateway, so you want to make sure to have a nice way to configure your APN. If you're talking cellular, you want to manage the firewall, maybe the NAT as well. And you want to also manage the set of OSGi components that are deployed in your gateway. You want to configure how the gateway is supposed to connect to an IoT backend, right? You want all your applications to have a nice high-level API for doing M2M/IoT communications with the backend. And so for that, there is an abstraction of what is actually an IoT server that you can configure in Kura. So I will actually show you how Kura looks like by sharing my header over here. So once Kura is running on your gateway, and granted that you actually have and granted that your gateway is actually connected to the internet, well, you can open a web UI that allows you to see what is basically happening on your gateway and can configure it, deploy new applications, etc., etc. So you can basically, as I said, manage the whole OSGi environment, like what are all the components, the bundles that are deployed. You can have a nice way to issue commands, like shell commands that will probably help you troubleshoot what's happening on your gateway. Like, I don't know, you're running out of disk space and you want to troubleshoot without having to open an SSH connection, etc. You can configure, as I said earlier, the network. You wanted to set up VPNs or PPP connections using a wireless modem, etc., etc. And network-wise, there's also the ability to open ports in your. Kura basically acts as a firewall, and you have a nice UI for developing your firewall rules, NAT rules, etc., etc. You can also install or upgrade applications. So here, what is really nice is that Kura leverages the OSGi standards, basically. So there's a standard in OSGi for describing software packages, basically a zip file containing OSGi bundles. And assuming that you have such a software package, you can actually deploy a new application. And all these applications that are deployed in your Kura environment can be configured from the web UI as well, by the way, as remotely. You can also issue MQTT commands for changing the settings of your Kura applications, and the kind of settings you might want to update and to change are, for example, the settings related, as I started explaining earlier, related to the IoT cloud communication. All the Kura applications will have a way to communicate with an IoT server in an abstract fashion. That is, when you write a home automation controller, for example, you don't want to bother hard coding or even knowing in your applications what is the server you're going to talk to and what kind of protocol you're going to use and stuff like that. So there's actually an abstraction in Kura, and in order to configure what actual server you're going to talk to at runtime, then obviously there are settings to do so, and you can, for example, as I've done here, you can configure Kura to talk to an MQTT broker that is the one that is set up at iot.eclipse.org, right? Or you can change this setting and talk to another cloud platform, another MQTT broker. So that's basically the idea of what Kura provides in terms of management capabilities. You can manage your network, you can manage your applications settings. And if I actually go back to my slides now that are here, the other thing that you can do with Kura is, well, not only manage a gateway acting as a firewall and as a gateway that will basically be always connected to the internet because you configured all your bearers, like the Wi-Fi, the GPRS, and so on. So you have basically your gateway, and now you want to deploy applications. And Kura applications can actually leverage not only Java APIs, the OSGi built-in APIs, but also some nice APIs and services that are part of Kura and that you can use when you build your own software components. So you can leverage a clock service if you want to to be notified whenever an NTP synchronization has occurred, because you want to be aware of that. You want to leverage the data service or the cloud service to talk to an MQTT server. You want to do ciphering, then you have a crypto service for doing that. You want to be location aware, you have a position service that will basically, in Kura, you will basically configure a GPS that is actually connected to your gateway. And once you've done that, then you have a position service that everyone can use to be aware of the current location of the gateway and react accordingly, right? So again, back to a practical example, I want to build a connected greenhouse. Well, I could quote my good friends from Bit Reactive who talk about the famous greenhouse example, but yeah, I think it's a very nice way to illustrate an IoT solution. Basically, I want to monitor the temperature, the humidity of a greenhouse, and I also want to be able remotely to turn the light on or off inside the greenhouse, because I want to be able to turn on some artificial lighting if needs be, right? So what I'm going to develop, what I'm going to build, is basically a set of OSGi bundles that that expose or consume services, OSGi services. So what I'm going to start with is a sensor service that will leverage Py4j for providing an implementation of a sensor service that will allow to manipulate the GPIOs of my Raspberry Pi, right? Like the temperature sensor or the LED of my greenhouse. And once I have such a service, then I can build another component that I will call a greenhouse publisher that will leverage not only the sensor service that I have just implemented, but also other services that are built in Kura, like the data service, the one that is abstracting the MQTT communication. So I will reuse this service, and I will, yeah, basically do a couple of things that I will show you right now by sharing yet another screen that's going to be my Eclipse ID, right? So this is the three-ish, four, five bundles. Well, the simulator doesn't count, I guess. The 4 bundles that are actually the code that will allow you to control my greenhouse. So in one bundle, I'm basically describing what is a sensor service. A sensor service is an API for getting the value of a specific sensor, say the temperature sensor or the humidity sensor. And I want also the ability to change, to update an actuator, like an LED. I want to turn it on or off. So that's basically one bundle just providing an API. Then what is the next step is actually to provide an implementation of such a service. And so for this, I have in another bundle, my Raspberry Pi bundle, I'm basically implementing the sensor service, and I leverage Py4j classes like the I2C bus API and the GPIO controller API, etc., to provide real meaning for the get sensor value API. Like, what does it mean to read the temperature? If someone asks me to read the temperature, then I need to do some I2C stuff, right? I need to send commands on the I2C device, and I will retrieve some kind of encoded temperature that I will need to convert and do some weird binary stuff. But anyways, I will, once I've done that, I basically have an implementation of the sensor service. And what I do, and I confess that it's probably going very, very fast, and if you're not very familiar with OSGi, you're going to need to like watch again and read in detail the tutorial I'm going to talk about at the end of the presentation. But basically, once I have this implementation of a sensor service, I can tell OSGi to actually expose my component, my Pi4j greenhouse sensor service, as an implementation of the sensor service. So once I have that, if you remember the last slide, the next step is to implement a greenhouse publisher. And what is a greenhouse publisher? It is a component that, if we look at the definition of the component, it's a component that will reuse the greenhouse sensor service as well as the Kura MQTT data service for doing stuff. And the stuff that we want to do is to actually retrieve data from the sensor, from the sensors, and publish the data using MQTT. So that's exactly what we are doing. And whenever a sensor value is updated, basically we leverage the data service for data using MQTT. And well, you cannot see the whole code here, but I swear that there's no reference whatsoever to iot.eclipse.org here, for example. I'm just using the data service, and eventually the data is going to be sent to the broker that is configured in the Kura web UI, right? And one nice thing that we do here as well is that we leverage yet another OSGi standard for describing configuration capabilities for our component. In this XML file, we actually describe some settings for our component, like what is the default topic for the data related to the greenhouse, what is the default QoS I want to use. And by doing this, once I build my application, my bundles, once I package them in the form of a software package that Kura can understand, then what happens, if I go back to my Kura web UI, what happens there is that, well, my application, once it's packaged, I can install it from the web UI, right? And my application is actually providing a nice new entry that you might have seen earlier. That is exactly what we've seen in Eclipse, right? These are the settings of my application, and I can update them right from the web UI. I can change the default MQTT topic, apply the settings, and my application, my software is going to be updated live, right? That's one nice feature of OSGi, that you can build very dynamic kind of software components. So that's basically how you would build the application using Kura. And another bundle that we haven't seen is the one that uses CoAP. We can actually, once we have a sensor service, it's actually pretty easy to provide another bundle that will also consume the sensor service and will basically declare CoAP resources for the temperature, CoAP resources for the LED, and yeah, you can basically have in the same runtime not only an MQTT publishing bundle, but also a bundle that will make your sensors available over CoAP. A trick here is that you need to make sure, if you want to make your CoAP resources available to the rest of the world, to go in the Kura network administration part to make sure that you open the UDP port for CoAP. And that's so that's basically how you would write the software running on the Raspberry Pi for exposing your sensors over MQTT and over CoAP. And once you've done that, at some point you probably want to actually see the data, right? You've leveraged Pi4j and Kura to make not only to build an IoT gateway, but also to build your own IoT application by leveraging the IoT Kura framework, basically. Once the data is available, well, if you are interested in consuming MQTT data, one thing that I really love and that I'm going to show how it actually looks like live is to use the MQTT over WebSockets. So basically, you need to enable, if you run your own MQTT broker, you need to make sure to have WebSocket support enabled. And if you use brokers, like commercial brokers, it's very likely that they have support for WebSockets. So then what you do is use the JavaScript API that comes with PAO, and you can build an application like the one I'm going to show you just now. And now I will actually share my whole screen. So I do have here. Okay, so this is my my Raspberry Pi with the sensors. So this is the LED actually. This is a temperature / humidity sensor, and this guy, we'll see later what it is. So that's my Raspberry Pi. It's connected to the internet, obviously, and it's running the application we've seen earlier. So now I need to find, yeah, this is my app, my Node.js, sorry, my JavaScript application that embeds the MQTT over WebSocket client. And so what is very nice is that it's an application, basically a web application with no backend whatsoever. It's really just JavaScript talking directly to the MQTT broker over WebSocket. And if I warm the temperature sensor, you can see it reacting live. And if you don't mind actually copy-pasting this URL and you want to try this at home, well, feel free to do so. You can actually, from your computer, open the very same web remote, I would say, and you can see the live temperature or turn the LED on or off. Hopefully you can see it, right? So that's all done in JavaScript. The code is actually very simple. Again, we won't go through the wall code, but basically, whenever, so this is implemented in Angular.js. It's not. It's well, basically there is a JavaScript framework helping us. And yeah, basically that's what happens whenever I press the button in the UI. I basically ask my MQTT JavaScript client to craft an MQTT message, and I send it to the broker, right? And whenever a new message arrives, well, I react also in the UI. Okay, so that's the JavaScript UI. Okay, and another thing I want to show you guys. So back to the slides. Is how to use CoAP. Of course, we've also deployed a bundle that exposes CoAP resources in my application. So what I can actually do, and this is where this is what we could call the real Internet of Things, in that with CoAP, the idea is that we're talking about hopefully the future of the Internet, which is IPv6, where basically every device is going to have an IP address, right? And once every device has an IP address, then that's pretty nice to have CoAP, since, well, basically if you want to know the temperature of a device, of a thing, then you just issue a CoAP get on that very specific device. And so, which is what is nice is that, well, my internet provider is actually pretty cool, and I do have an IPv6 network at home, which means that my Raspberry Pi actually has an IPv6 address as well. So if I go back to here, this is actually an HTTP to CoAP bridge that's available online, and this is the IPv6 address of my Raspberry Pi. And by just issuing a get on the root node, basically of my Raspberry Pi running a Kura and a CoAP server, then I have the ability to discover all the resources that are available in my application. And in this case, that would be some sensors, a temperature sensor, a light sensor, as well as actuators. And if I go to the temperature, and if I try to warm the sensor for a while, refresh the resource, then, well, for some reason, it's not that warm, but we can see that it gets updated, okay? And what we can also do with CoAP, and hopefully the demo is going to work, is to use radio network. So this guy is also a thing in the Internet of Things that communicates using radio, and this is battery powered, pretty much like ZigBee, if you will. And this is very small, very constrained device. It has like 48K of flash, 8Ks of RAM, I think. Very, very constrained device, but still it runs an IPv6 stack and a CoAP client. And so what I can do is actually press a button to turn the LED on or off. And this is not going to work. Yes, it does. It does work. So that's actually something that's being done over radio, and I could have left this guy over here open to show you that whenever I press the button, then my MQTT UI stays in sync, right? So that's basically what I wanted to show you guys today. Let me go back to here. So that's yeah, just the slides for asking you. Would you have a question? Oh, Dave would like me to copy paste the URL. Could I do that? That's a good question. I will use. So there's a question on the Q&A for people who want to play with this. So I will share. If you guys go to the showcase, hopefully you're using Hangouts, and you're going to be able to see the greenhouse control as well as the CoAP URL, the coap.me. It works. Let's paste the coap.me URL. So that's what I had. It's really about presenting you guys the framework that is Eclipse IoT in like a real framework, right? You have Kura and OSGi for providing you with all the framework for making sure that you have reusable software components like the sensor service, the MQTT publisher, etc., plus all the framework for building software packages that you can deploy in the Kura web UI. And that was also hopefully, and now I see the LED blinking. Some people are actually playing with it. That's pretty cool. So yeah, it's also a nice, I think, introduction to our webinar next week, where Matthias Kovac, project lead from Eclipse Californium, is going to talk in more details about the about how to build wireless sensor networks. So that will be something that that I hope you guys will attend. And with this, I will ask you if you have questions. So I don't see any more questions on the Q&A right now. Roxanne, did we have questions on the on Twitter maybe?
No, there are no questions so far. So they can always email us at iot@eclipse.org. And I believe we have a question to ask them, so they can win the greenhouse kit.
Yes. So this fun set of sensors that I've used for the demo today. Two things. We are actually preparing Java 1 at the end of the month, where we're going to present in more details all these projects and how people should actually use them. So as part of this Java 1 stuff, there will be a complete tutorial for building the very same application that you've seen today. So you should check it out if you're interested in building the same application. And for building this application, you will need hardware, right? You will need a Raspberry Pi, you will need the sensors. And in order to win them, and we still have many people are actually watching the channel, so you will answer that very simple question: what is the name of the open source implementation of CoAP in Java that we have at Eclipse? So first person who's going to send us the answer at iot@eclipse.org email address will win the complete kit with the Raspberry Pi and all the sensors for replicating the demo. So be quick.
Good luck.
Yeah, that's really an easy question, right, Roxanne?
Hopefully.
Yeah. So with this, I thank you again. Feel free to ping me on Twitter, or as Roxanne said, on iot@eclipse.org if you have any questions on the webinar. It's recorded, so it's going to be available on YouTube right after the. Oh, we actually have a question from Ignacio, and it's going to be very easy actually to answer that one. Really cool. Kura, does it bundle the MQTT broker? Well, nope. In that, with Kura, the idea is that you're really building embedded side of the network. So you would probably, I mean, you can, if you want, embed like Moquette, for example, inside Kura, if you want to provide an MQTT broker for the sensors that are behind your IoT gateway. But usually Kura will rather talk to a broker that is in the cloud, right? That is on the internet. So yeah, long story short, there's no broker embedded in Kura. If you really need to, you could, though. Well, we have many questions right now, so let's just answer them. And first, I think the first question was, I had a question on lightweight M2M and the possibilities with Arduino. Well, Davey, it's not a question. So you had a question, but if you don't tell us more details, it's going to be hard to answer that. So maybe we can discuss that on Twitter afterwards. And for Ignacio, what is the radio device? So it's called a mode. It runs Contiki, the Contiki OS, which is a very small open source operating system for microcontrollers. And so this one, well, I can send you the details privately on where to order that one. It costs like 60 euros, I think, and it does 802.15.4 radio protocol. Again, just like ZigBee, and yeah, you basically use C to program your application. You can use as I said, you can run a CoAP client, CoAP server, and that's a pretty neat device. And you can also plug it to a Raspberry Pi to turn your Raspberry Pi in a 6LoWPAN router, basically. That's pretty cool, and hopefully there will be more details in the tutorial I mentioned earlier. So yeah, I don't think we have any more questions. So hope you guys enjoyed it, and yeah, please tune in next week, same time, for hearing Matthias about sensor networks. Thank you.
Thank you.
Bye-bye.